Hi, see you again. Now, let's focus for the correlation. Just now, I started to explain to you about the regression, we have gone through some of the examples related with the correlations. So, let's recall about the smoking strongly related to the indices of the cancer. Student achievement is correlated with their attitudes. The price of chicken varies with the season. Highest rate enable the workforce to be more productive. We can see that based on these two variables, it will affect either, I give the example, the student achievement and also the attitudes. The more positive the students, logically, the higher chance of the student to get a better achievement, meaning that attitude good, increase, achievement also will be increased. So you will get increase and also the correlation also become increased for the second variable. And let's take a look for the first example, which is smoking and also the incidence of cancer or the chance to get a cancer. The more you take the cigarettes, meaning that the higher chance to get a cancer. So meaning that increase independent variable, it also will increase for the dependent variable. So these two examples, you can see that they are directly proportional with each other. Some of the example, you can see that they are indirectly proportional, and somehow we cannot see the correlation between of that. Why this happened? So that we can figure out all this relationship based on the correlation test. So what is a correlation? Correlation analysis is attempts to measure the strength and magnitude of the linear relationship between two variables by means of a single value called a correlation coefficient. Compared with the regression, we can determine more than one's independent variable correlate with the one dependent variable. But however, in a correlation analysis, we can just correlate to determine the relationship between two variables, which is one independent variable and one dependent variable. And correlation analysis deals with a single value that measures the strength and the direction of the linear relationship between the two variables. Meaning that based on the correlation analysis, it will tell you and will provide to you a one single value, which is can describe the strength of the relationship between these two variables. Let's take a look at the properties of the correlation of the coefficient. There are several properties listed below. The first one is the anchor knowledge of the properties correlation, which is the value of R or the coefficient of the correlation is from -1 to +1 only, meaning that it cannot be less than -1 and it cannot be larger than +1. That is the basic one. Number 2, values of R close to +1 imply there is a strong positive linear association between X and Y, and if the value are close to -1, imply that there is a strong negative linear association between X and Y. And number 3, values of R close to 0 from either direction imply weak or no linear association between X and Y. And the last one, the value of R has no scale regardless of the units of X and Y values. So, based on that value, we can categorize the type of the correlation into three type of correlation. And based on this type of correlation, it based the value of the R. Since I have mentioned just now, the range of the value of R is from -1 to +1. And therefore, we can see here we have three types of correlation. The first correlation is a positive correlation, meaning that if the value of R is the value of positive, is indicated as a positive correlation. And if the value of R is a negative values, meaning that the type of correlation is a negative correlation, and if the value of R is 0, therefore there is no correlation. So the population correlation coefficient is commonly denoted as a P rho. So like a P symbol, but this is called as a rho, and estimated by the Pearson product moment correlation coefficient denoted by R and expressed as R equal to SXY over square root of SXX times SYY. What is SXX and SXX SYY? We have discussed how to determine the value of SXLI, SXX and SYY in the previous discussion, which is regression. So this is the scatter plot. How is the positive and negative and also no correlation is look like? So we can see at the first one, strong positive correlation. So you can see that the point of the data is scattered almost at the straight line, and this is a positive straight line. And this is considered, the second one is considered as a weak positive correlation of the scatter diagram. And for the third one, we can see this is the example of the strong negative correlation. You can see that the data or the point is almost at the line, on the line of the straight line of the negative line, and this is the weak of the negative correlation and dispersed, and you have more extreme values compared at the strong negative line for number 4. And the last picture is number 5, is a scatter diagram, how there is no correlation, which we cannot come up with a one straight line either positive or negative. And strong correlation indicated by the close scatter and around regression line, and weak correlation indicated by side scatters around regression line. Now let's take a look at the example. So reconsider the data that we have discussed in a regression before, which is a statistics score of the students with their CPA, and meaning that their independent variable is a statistics score and the dependent variable is a CPA score of the students. So in order to determine the correlations of the student between the statistics score and also CPA score, we will determine the value of R. So the value of R is equal to SXY over square root of SXX XYY. So based on the previous example, we have determined that SXY is equal to 30.87 divided by square root of SXX XYY. So we will get 956.1 times 1.0952 square root, and we got the R is equal to positive 0.9540, and thus this indicates that the value have shown a very strong positive relationship between CPA and also the statistics score of the student. Now, based on the example that I have discussed with you just now, please do this example, which is relate with the horsepower as an independent variable and fuel efficacy Y as a dependent variable. So please recall back how to determine the SXY and SXX with the SYY and substitute into the formula of R SXY over square root of SXX SYY. Okay, if you have done it, you will get the value of R is equal to negative 0.9442, and since this is quite different with the previous one, and because we will got a positive, highly positive relationship, but for this example you will get R equal to negative 0.9442. Thus this implies that highly strong negative relationship between the horsepower and the fuel efficacy. Okay, I also have prepared for you some of the quiz question. So you have A and B. So please do the question. Okay, as a revision and for you to look what is the answer. So I have prepared the answer for the quiz just now. So you will get A, R equal to negative 0.9542 and B is equal to positive 0.8128. Alright, thank you. Thank you so much for your attention. Bye bye.